This is Jeff at Rhodes College, and I'm going to talk with you for a few minutes about creating a couple of different visualizations of the randomization distribution, that is the distribution of the measures that we collected during our last screencast. So recall that what the setup is here. We have a dichotomous by dichotomous set of data related to an experiment performed by a French psychologist. We have learned how to sample without replacement from the original set of data. We defined a measure on those samples taken without replacement. Namely, we counted the number of times in the samples in which the male approached the female at the bar. And then we aggregated together many of those counts over many different samples without replacement into this measures box right here. In fact, we did so during the last screencast 1,000 times. There are going to be two ways that we will want to visualize this distribution of measures, which again we will call our randomization distribution in this class. One visualization can be achieved by taking this graph icon here in the upper left-hand corner and drag it down somewhere, say here. It's empty right now. To fill it, drag the name of our measure that we defined from a table that was generated from the measures box down here. Fathom is going to default the choice of graphic to a dot plot. You may not want a dot plot. In fact, sometimes this semester we're going to want to use a histogram instead of a dot plot. But for right now, let's just work with the dot plot instead. Okay? The other thing that we'd like to do with this randomization distribution is plot the measure that we've been working with, that count of approaches, as it was taken with respect to our original set of data. Not a sample without replacement, but with respect to the original set of data. So recall in our original set of data, thinking about the number of times that the men were only glanced at the bar. They weren't smiled at, they were just glanced at, as being the samples of size 10 that were repeatedly and artificially sampling from the original data set. We had only two instances in that original data set in which the men ultimately approached the women at the bar. So I'd like to plot that on my randomization distribution. And the way we do that is to right-click on this graph and click Plot Value. And I'm just going to enter the value of 2, since that's what we observed in our original set of data. And we have here two things: the randomization distribution, these columns of dots, and this blue line, which represents the measure taken with respect to the original set of data.